So it gives me absolutely great pleasure to kick off another Bevan Series seminar. I'm Trevor Branch, and I'm on the faculty here at the School of Aquatic and Fisheries Sciences. And I run the Bevan Series, at least the small parts that are left over after Sherry has finished running the rest of it. It gives me great pleasure to hand over now to Aaron Worsing from SEFS, the School of Environmental and Forestry Sciences, to introduce our speaker today, Nick Dulvy.
Thank you, Trevor. And let me take a second to welcome you to another installment of the Bevan Series. Our speaker today is Dr. Nick Dulvy, Professor and Canada Research Chair in Marine Biodiversity and Conservation at Simon Fraser University in the Department of Biology in Burnaby, British Columbia, Canada. Now, Dr. Dulvy originally comes to us from Northern Ireland. While in the UK, he earned a Bachelor of Science degree in Animal Zoology from the University of Birmingham, and later a PhD in Evolutionary Ecology from the University of East Anglia. At his current post at Simon Fraser University, he is a member of the newly minted Earth to Ocean Group, an interdisciplinary team of scientists devoted to addressing global environmental issues through the use of collaborative multidisciplinary science. And he is also co-chair of the IUCN Shark Specialist Group. Now, I'm really excited to introduce Dr. Dulvy to you for a couple of reasons. First of all, his current institution, Simon Fraser University, happens to be where I earned my doctorate in biological sciences back in 2005. Second, much more importantly, his research program addresses a diverse and impressive array of research questions in which the goal of the Bevan series, namely to find solutions to the complex problems that arise from sustainable fisheries, is clearly manifest. Now, to give you just a few examples of what his research program does, it explores trade-offs, for example, between different fisheries policy objectives. It explores indicators of biodiversity, effects of climate change, and threat status of large predators and marine ecosystems. It explores decision-making and motivations of fishers as a means to achieve desired management outcomes. It explores the evolution and ecology of sharks, and finally the impacts of bleaching, fishing, and other stressors on coral reef ecosystems. Now, the title of Dr. Dulvy's talk today is Saving Nemo, the Science of Marine Extinctions. And with that, I'm happy to turn the floor over to Professor Nick Dulvy.
Good afternoon. I'd like to start first off by thanking Trevor for very generously inviting me to come here, for Sherry for facilitating my visit, and Aaron for such a wonderful and very generous introduction. Without any further ado, I'll take you to the point of departure for this talk. It might seem odd to come to SAFS and show you a picture of sand bushland, but this is to set the context for the talk. And the context is that human societies started off small, foraging and hunting. All of that changed irreversibly about 10,000 years ago with the invention and advent of agriculture. Since that time, and indeed in the last 50 years, we've transformed more of the Earth's surface and bended it to the plough than we've done in any other period of human history. To the point where now, fully 1/3 of the land surface of the Earth, the ice-free land surface of the Earth, has been converted to cropland. This has not been without consequence for biodiversity. Sure, we've facilitated rapid human population growth and a rapid increase in well-being, but at the expense of biodiversity. There have been substantial numbers of well-documented extinctions of mammals and birds in particular, and the rate of extinction is rising to the point where, at least up until 1950, there was at least one species extinction of a mammal or bird per year. This isn't just an esoteric stamp collecting exercise. Biodiversity matters. And one way of thinking about how biodiversity matters was laid out by the Millennium Ecosystem Assessment. They laid out this typology whereby biodiversity, life on Earth, underpins 4 classes of ecosystem services. Supporting ecosystem services that underpin provisioning ecosystem services, regulating services, and cultural ecosystem services. You might think that these are very abstract ideas, but think about provisioning ecosystem services. What did you eat today? Where did your clothes come from? What is your house made from? If you don't agree that ecosystem services aren't important, then I suggest you hold your breath for the next 3 minutes. Because that oxygen that's fueling your body and the burning of food all comes from plants. All of these ecosystem services have been shown to map onto constituents of human well-being. These constituents of human well-being provide us with what it is to be a human being: freedom of choice and action. And the key elements of freedom of choice and action require security, basic material for good life, health, and good social relations. So at some very deep level, biodiversity underpins ecosystem services, which in turn underpin life itself and for humanity. Stepping away from what we know on land, I think Arthur C. Clarke put it in a very appropriate manner when he said, how inappropriate to call this planet Earth when it's quite clearly ocean. The bulk of the world is ocean. And in that context, my research vision, this isn't my research vision this year, but I think it's my overarching research vision for the next decade or two, will be that the key fundamental scientific challenge of our era, of our generation, is to value, conserve, and restore biodiversity while maintaining ecosystem services and securing the benefits for humanity. I personally seek not just to research and understand that, but to communicate the consequences of our options and our societal choices for biodiversity and ecosystem services. The policy imperative for me personally is the Aichi Conventional Biological Diversity Targets, notably Target 6. This is within strategic goal, which is to reduce the direct pressure on biodiversity and promote sustainable use. Now this holds us to a really high bar, whereby by 2020 all fish and invertebrate stocks and aquatic plants are managed and harvested sustainably, legally, and applying ecosystem-based approaches so that overfishing is avoided, recovery plans and measures are in place for all depleted species. All depleted species. Whereby fisheries have no significant adverse impacts on threatened species and vulnerable ecosystems, and the impacts of fisheries on stocks, species, and ecosystems are within safe ecological limits. So my research questions at the very broadest level are, what are the nature, scale, and trajectory of major environmental changes? What are the impacts on biodiversity, ecosystem services, and to some degree, human well-being? I'm obviously not a social scientist, but I do work with collaborators on human well-being issues. And what are the options? What options do we have for managing any of this? I don't do this alone. This is a vision shared by the Earth to Ocean Research Group at Simon Fraser, which is a very young research group which has appeared out of nowhere in the last 5 years. Some of the characters you may be familiar with, some you won't be. Isabel Cote is a tropical coral reef ecologist. Larry Dill is a behavioral ecologist, best known for his work on the ecology of fear and by spawning out people like Aaron Wersing. Myself, Jonathan Moore, Wendy Palin, and John Reynolds, and we've been thoroughly infected by SAF's ideology. Jonathan Moore and Wendy Palin are, of course, graduates of SAF's and UW. Now, one of the key challenges is that as an ecologist, we really want to understand the mechanistic causality. But to be honest, the scale at which we can understand causality in ecological systems is not the scale of relevance to policymakers. So my mode of research tends to focus on the right-hand end of this scale, where very often we can't do anything else but infer causality. We certainly can't test it. So I'm an unashamedly comparative biologist. I draw inferences about the state of the world at large spatial scales through comparative analyses of populations, species, communities, ecosystem, islands, and nations. My study systems are incredibly diverse, working from 9 o'clock round. The white ones are local study systems. I've worked on the ecosystem effects of fishing in Fiji, Christmas Atoll. I worked in the Caribbean, mainly trying to understand region-wide collapse in coral cover. I work in kelp forest ecosystems. A lot of my career has been based in the North Sea, where I was actually a government policy advisor in the equivalent of NIMS-NOAA in the UK government. I started off, I actually got into ecology through working in Tanzania. So So aside from those local experiences, what you may not be able to see in red here are the global scale type meta-analyses that I have worked on, including global vulnerability of fishing nations to the impact of climate change on that part of the economic sector. Most recently, we've been very interested in looking at the link between thermal physiology, species distribution, and the change in distribution due to climate change. And that's not a marine project, that's actually a marine and terrestrial project. I've also been very interested in the degree to which fisheries are imposing a footprint with respect to how much primary production we're removing, both from planktonic-driven systems, but also coral reef ecosystems as well. And last but not least, the area that I'm going to focus most on today really is my long-abiding interest in the evolutionary ecology of chondrichthyans, sharks, rays, and chimeras, and more recently in the conservation biology and conservation problems that they face, which of course are clearly very fisheries problems. The Earth to Ocean Research Group, like many other research groups around the world now, tend to focus on a paradigm broadly similar to this, whereby we're very interested in how natural and human pressures influence populations and how the interactions among populations and community dynamics are affected and ecosystem connections are affected. We're obviously very interested in how human dynamics and decision making and the use of these systems is influenced through conservation and management action. So after a long preamble, what I really want to do is to get to the point to define where exactly my work will be for the next 45 minutes. So today I'm really going to talk about only one aspect of my work, which is the effect of human pressures, particularly climate change, habitat loss and fishing, on populations and species. This isn't a new question, this is a very old question, and one of the first people to frame it in a memorable fashion was Thomas Henry Huxley in his 1883 inaugural address to the meeting of the Fisheries Congress in London. He asked whether fisheries are exhaustible. That is to say, can all the fish which naturally inhabit a given area be extirpated by the agency of man? Very often this quote is used to state that fisheries cannot be exhausted. But Thomas Henry Huxley was very clear in saying that he actually believed that fisheries could exhaust small populations in small locations. And he gives the example of where he believed that salmon fishers could extirpate salmon from a stream. But he went on to talk about marine fisheries. And from his perspective from London, in the late 1880s, before the industrialized fishing fleet, whatever fishing fleets there were sail-powered and only nibbled around the coast of Great Britain. This map here is a map of the distribution, the extent of occurrence of the blue shark, and this is probably the greatest exaggeration of a marine species range that I could give you, but it typified his thinking in that many of the species he was looking at the fishermen catching, like cod and plaice and sole and other flatfish, had very broad distributions. And their distributions meant that there was very little intersection between the fishing fleet and the distribution of the species. So he argued that at that time, these fisheries could not be driven to the point of extinction because there was very little overlap and exposure to the fishing fleet. He also argued that intrinsically fishes were way more resilient and capable of replacing numbers lost to fishing because of the inordinate fecundity of fishes. We now know that that's a fallacy. We now know that fish are inordinately fecund because they have to be to capture any of the energy in that highly productive but highly patchy phytoplankton bloom. We now know that the intrinsic rate of population increase of fishes is more akin or even lower than mammals or birds, but that's another story that I'll get into later. But he thought about extinction risk in terms of accessibility to the fishery and the intrinsic capacity of the biology of the species to cope with the mortality. So with this backdrop, we spent some time thinking about how many marine species might have disappeared due to fishing. And the reason why we thought about this was because everybody was saying we can fish harder because we're not doing any damage, because there haven't been any extinctions. So we weren't obviously the first people to think about this. James Carlton started this off with a review in 1998, and IUCN summarized this in 2004, and we went back to the issue again. So the story to date is that there have been 20 global marine extinctions of mammals, birds, fishes, mollusks, and algae. So it's mainly air-breathing mammals and birds. Even this doesn't seem like very much, given that there's 2 million species out there and we've lost hundreds of birds and mammals and amphibians already. So I'm just going to put some faces to those numbers, and since our review of this was published, a series of papers have come out strengthening the evidence for these extinctions. And one of these is work done by Andy Cooper, another graduate of SAS. You can see prior to the exploration of the Caribbean in the 1700s, the Caribbean monk seal was distributed throughout the Caribbean. As explorers went through the Caribbean, stocking up their fridges with monk seals, the range contracted to the point where they were found only in the core of their range by the early 1900s, and the last sightings were made in about 1952 in the center of the Caribbean. This is generally the story of monk seals the world over. There's 3 species, there are 2 still remaining, but they're tiny, fragile populations in the Mediterranean and Hawaii. If you want to know if a marine fish has gone extinct, it's getting pretty close to being incontrovertible that this species is the poster child for climate change. Forget polar bears. The Galapagos damselfish, as many other damselfishes, are very closely associated with hard coral habitat. They're planktivorous species, and with the rise in intensity and frequency of El Nino Southern Oscillation events, such as the 1983 event, which was the second strongest El Nino on record, these corals have been bleached and destroyed, so the habitat has been lost due to these very intense bleaching events. This species has not been seen since 1983, despite targeted searches for it. So Graham Edgar and a whole series of colleagues have been out to the Galapagos to look specifically for this fish, and they have not found it. Also, the greatest canopy-forming algae in front of the Darwin Marine Station there, we think, is extinct. It's the endemic algae to the Galapagos. So we decided to set the bar a bit lower and think about population extinctions. And there's very good reason why we should think about population extinctions. First off, we tend to manage, not at the species level, but at the population level. Second off, population extinctions are the stepping stones to global extinction. So these potentially are the canaries in the coal mine for a much more serious problem. Maybe because we've been impacting our ocean not for 10,000 years, but for maybe 50 or 100 years, we can only see these as harbingers of a greater problem coming out in the future. So with surprisingly little effort in a very unsystematic view of the literature, we uncovered evidence for about 133 local, regional, and global extinctions. The global extinctions I've already told you about, but I'll just talk to you briefly about the local and regional extinctions. By local, I mean not Puget Sound. I mean more on the scale of the Irish Sea or the North Sea. By regional, I mean on the scale of the Gulf of California or the Mediterranean Sea. So these are very substantial sea areas. And these are some of the animals that have disappeared from very substantial sea areas of the world. And I can talk more about the details of these and the methodology afterwards, and we'd be very happy to do so. We can think about the causes of these disappearances, and that data is shown on the top graph. It's very hard to attribute a single cause to any one of those case studies. But where we can infer that the bulk of them have been driven to local, regional, or global extinction due to exploitation, followed closely by habitat loss. An independent data set published a couple of years before by Jack Music, which looks at marine estuary and diaphanous fishes at risk of extinction in North America, exclusive of Pacific salmonids, came up with virtually identical proportions of threatened processes. So the overwhelming threatening process up until the early 2000s was overexploitation. I'll just step back a second and just say something about the permanence of those extinctions. We actually looked to see when the beast was likely to have gone extinct and then when it was reported to have gone extinct. On average, the median gap between those two dates was 50 years. So we're pretty sure that these things have disappeared from large sea areas and have been disappeared for a very long period of time. That's also worrying for a second reason, because it means that the currency of our knowledge of the state of the environment is not very current. It's very out of date. So I put it to you that it's incontrovertible that at least at some level, marine biodiversity at the population and species level has been permanently lost. The key question for me going forward is how bad could it get? How many marine species could go extinct? And I'm going to try and address that with 2 recent studies of ours. Before I do that, I have to talk to you a bit about methodology. The methodology that I'm going to use throughout the rest of this talk is a methodology devised by the International Union for the Conservation of Nature. It's called the Red List Categories and Criteria. These were first used in the late 60s and have changed over time, but a very stable methodology was devised in the year 2003. I'll take you through it briefly. There's 5 criteria, but the 2 criteria we tend to use in the marine environment are based on the rate of decline of population size or being spatially restricted in a small area. There's a whole swath of other stuff that I could talk about, but these are the ones that are pertinent to today's talk. And the idea is that you have decline thresholds, not necessarily decline thresholds by calendar year, but they're decline thresholds in dog years. Okay? In the same way that you convert your dog's calendar years to dog years, we use generation times to scale these declines in the IUCN criteria. If you breach a threshold of greater than 50% decline over greater than 10 years or 3 generations, then you're assigned a vulnerable categorization. 70% for endangered, 90% for critically endangered. If you don't quite meet those thresholds, you're assigned a near-threatened categorization. If you're not declining, then you're assigned a least concern, which effectively means you're safe with no risk of extinction. If there isn't sufficient data to make a determination, we assign those species as data deficient. But it's worth bearing in mind, those data deficient could be safe, as in least concern, or they could be highly threatened or close to extinction. But the Red List assessment is not just about declines and extinction risk per se. There's a whole swath of other data that go into the assessment that are actually pertinent to the conservation biology and management, such as taxonomy, distribution, habitat and ecology. There's a whole area for documenting the threats that are faced and the potential conservation actions that could benefit the species. Many of you might think that shark science involves zipping around on boats, tagging stuff. The reality of shark science and much of marine conservation is this. So with a bunch of red listed species, we can now ask some questions about the future of marine life. So we can ask, what is the minimum proportion of marine species at risk of extinction? And the way we did this was by focusing on charismatic species. And the rationale for doing that is that charismatic species are most likely to garner the greatest support from the public, and therefore from the research community, for their conservation. Therefore, these represent a best-case scenario for the fate of marine biodiversity. The next question is, how do you get a sample of charismatic biodiversity? Well, there's lots of ways that you might want to think about doing that. We actually chose this way. We reasoned that Disney would not make a film with ugly animals. So we took the film Finding Nemo as a sample of charismatic animals, however imperfect that might be. So we can now ask the threat status of some of the most charismatic animals in the ocean. There are 16 species from 16 taxonomic families that had speaking parts in the film Finding Nemo. In those taxonomic families, there are about 1,500 species. And when I say we, I mean they, as in Lauren McLennigan did all of this work. She's an NSF PDF based with us at Simon Fraser. Now, when thinking about the health of the ocean, it's always worth thinking about biases. And you're all sitting there going, oh my God, I can't believe he watched the film to get his data set. And it's true. Now, there are biases, good and bad, about this. And when you actually think about it, the biases are actually very interesting and useful in this case. Sure, we've got reef species and large pelagic animals. We're not so good on all the other charismatic stuff. You might think, oh my God, that's a totally irrelevant location to have any bearing on the consequences of fisheries for the world ocean. But I put it to you that given that all of the world's biodiversity, or a very, very large proportion of it, is in the Indo-Pacific biodiversity triangle, you'd want to take a sample from the Indo-Pacific biodiversity triangle, and that's effectively what we've got here. So geographically, it's probably more representative of marine biodiversity as a whole than any other part of the world. So the short answer is we pulled out all of the red list assessments. Turns out there were red list assessments for about a third of these species. And the short answer is that 16% of these charismatic animals were threatened with an elevated risk of extinction. There was considerable variance among the families. Sharks are more threatened than, say, for example, fishes. And if we break out the drivers of threat, we again see that exploitation is the overwhelming driver of threat, and habitat loss still remains an important cause of threat. But a decade on, we're now seeing the emergence of climate change as a significant threatening process to marine biodiversity. And that's not surprising when you take a coral reef sample. We've lost a third of the world's coral reefs due to the 1998 El Nino Southern Oscillation bleaching event. So we've lost a lot of habitat. So that's a pretty cutesy, folksy, whimsical way of thinking about marine extinction risk in the ocean. But it does give a lower bound to the extinction risk in the ocean. But what you'd really want is an unbiased sample from some broadly distributed taxon that lives throughout the world's oceans, so that you'd have an unbiased sample. Well, we have that. And that's what I'm going to talk to you about next. That unbiased sample comes from a red listing of an entire evolutionary lineage, that of the sharks, rays, and chimeras. The problem with sharks, rays, and chimeras is that they run with some of the most valuable fish in the world. So if we think about the tuna, billfish, swordfish fisheries of the world, we can classify their management status on a Trevor branch plot, which is B over BMSY. So it's the biomass relative to the sustainable take, which is this line here, and it's the fishing mortality associated with that, so sustainable fishing mortality here. So what you really want to do if you're a fisheries manager is put your stocks on the crosshairs, and if we look at the 26 populations of the 12 scum-bred fisheries of the world, some of the most valuable fisheries in the world, they're by and large doing a pretty damn good job of managing them sustainably. Indeed, some of them are extraordinarily healthy. There are some absolutely woeful and egregious examples of overfishing. These fish are literally too valuable to conserve. The last price I saw for southern bluefin tuna was $750,000 for a single individual. So it's not surprising management is not as effective as it might be for the less valuable tunas. But my point is here, from a single species perspective, these tuna fisheries are largely sustainable. The problem with tuna fisheries and tuna fisheries management is that they don't really have objectives for all of the collateral damage they're doing to the world's oceans. And some of that collateral damage is bycatch of turtles, seabirds, and sharks. Sharks are rarely taken whole. Their fins are removed. They enter the fin trade to go to Hong Kong to provide a kudos product for Chinese weddings. And the problem with all of this process is really that if you're catching both species at the same rate, the lower productivity of the chondrichthyans mean that it's inevitable that they will decline in a very dangerous manner while the albacore fishery is doing just fine. This is the problem with sharks, is nobody really cares about bycatch. In fact, the world fisheries globally really don't do much about bycatch. So I don't know if you can see that, but each rack has got fins on it. Now bear in mind that 7 fins per shark. So you can quickly see that each one of those squares of the big fins is probably 5, 6 sharks. If you calculate it all up, you're looking at 1,000 to 2,000 sharks. It takes about a week to dry some fins and then they'll all be replaced. You know, 1,000 to 2,000 individual sharks is, for some species, a population. The key question is really, is any of this sustainable? Should we care? Should we be worried about it? So one of the supplementary questions is how many sharks are killed each year, and there's only one person who knows the answer to that, and that's Shelley Clark, who risked her life. She was given multiple death threats to work in the fin markets of Hong Kong to figure out how many fins were passing through from what sizes and what species of shark. From that, she calculated 38 million sharks a year were passing through the global market for shark fins. You can contextualize that by looking at the reported catch to the Food and Agriculture Organization of the UN. It's about 800,000 metric tons a year, of which about half of it are of sharks that are likely to enter the fin trade, whereas Shelley's data reckoned that 2 to 4 times that amount was actually passing through Hong Kong and southern China. So we are globally blind to the scale of global shark catch. These FAO catch statistics are not even remotely close to the reality of what's happening in the world shark fisheries. We still go back to the question of, is that too many? Is that about right? Is that good or is that bad? Well, some insight to whether that's good or bad comes from a few small data sets, notably compiled by Julia Baum. And this is just a fragment. This is from observer records from commercial longline vessels in the Northwest Atlantic of hammerheads in particular. And here we have the raw data. The quick summary is that there's been an 88% decline in hammerhead catch rates over a period of 15 years. That's about 1 generation, so an 88% decline in 1 generation span. Compare that to elephants. Elephants are listed as vulnerable on the IUCN Red List because of a 30% decline over 3 generations. So these are some of the steepest population declines that IUCN scientists have ever seen. The next question is, well, that's only a tiny chunk of the distribution of hammerheads. Is that decline representative of the species as a whole? Or is it just a unique phenomenon to the Northwest Atlantic? And that's really where the IUCN Red List process comes in. We bring everybody together who knows something about the pattern of fishing, the patterns of catchability and so on throughout the world's ocean to kind of try and extrapolate out from this and draw some sense from the available time series from the other ocean patches around the world. So this was all done by the IUCN Shark Specialist Group, and we have 171 members that work through 12 regional groups in 55 countries of the world, and it's entirely a volunteer network. So the results I'm about to show you now are the result of 10 years of work, 17 workshops. There was a whole series of preliminary workshops involving more than 300 people, 306 people I think, and we managed to assess 1,041 species of chondrichthyon, which is nearly all. The number of chondrichthyons is a shifting baseline. A new shark is discovered virtually every 2 or 3 weeks, and that's been the case for the last 30 years. So the punchline, in red so you can't see it, we think that a quarter of the world's chondrichthyons face an elevated risk of extinction. Let's put some faces to that. There are 25 species in the highest category, the category of critically endangered. They include species with large geographic ranges that have been caught indiscriminately as bycatch of large-scale trawl fisheries in the Northeast Atlantic. This beast, the angel shark, is probably extinct from the Mediterranean and from the entire Northeast Atlantic, apart from the Canary Islands. You can actually dive with these in the Canary Islands. It's not just large range species. There are a whole series of small range endemics, including this wonderful beast. So named, it was discovered in the last decade, and it was named because of its very particular feeding habitats or feeding mode. And this species is found, its distribution centered on Durban. It's found in water less than 100 meters deep, and its range spans 300 kilometers. Think of many of the marine species you work on. That's an absolutely minuscule range. This is like the amphibian of the shark world. You may or may not know or be aware that there are a whole swath of freshwater chondrichthyons, mainly in the Amazon basin, West Africa, Southeast Asia, Northern Australia. This is one of the more notable ones. It was called Hymantura chaiofraya because it's found in the Chaiofraya River that runs through Bangkok. If you've ever been to Bangkok and looked at the river, you will know why this is critically endangered. It's inordinately threatened by enormous amounts of habitat loss and degradation due to development along the watershed. And it's also fish. So here today, I'm afraid this projector is not going to do the colours justice, but this is the map of species richness of all of the world's chondrichthyons on a 22,000 kilometre cell size scale. So here are the hotspots of biodiversity: Northern Australia, Southeast Asia, basically the Indo-Pacific coral biodiversity triangle. There's notable diversity stretching out through India to the Red Sea. You can't see it here. There's another hotspot here. There's inordinate diversity in West Africa, also in the Caribbean, notably spanning the Panama Isthmus, which closed off 3 million years ago. There's a whole series of endemics either side of that isthmus. So I can show you the map of where all the threatened sharks are in the world. So the thing to note here is this blue stuff. Basically, sharks are threatened, or threatened sharks are found in everywhere in the ice-free waters of the world. There is not really a part of the world's waters that's free of ice that does not have a threatened chondrichthyon in it. The map of threat closely follows the map of species richness. So again, threat is highest: Southeast Asia, India, Red Sea, Gulf of Aden, southwestern Indian Ocean, from Namibia almost up to Norway, and South America. There are a lot of deep trawl fisheries there that are causing some problems there. There are also a series of knowledge gaps. What I have not yet told you is that of the 1,041 species, 46% were data deficient. We could not make an assessment of their status. This is the heat map of data deficient species. So up here, beg your pardon, Japan, China, there are cells there with up to 50 species where we don't know their status in some of the most heavily trawled areas of the world. There are also data deficient areas: West Africa, Caribbean, Eastern Pacific. So one key question is, who's doing all of this? Who's responsible for this? And one way of thinking about that is to look at each country's share of the global catch of sharks, however imperfect that FAO data might be. The key shark fishing nations of the world are Spain, India, and basically Indonesia, along with the US, and I think that's Argentina. One of the key issues is European fisheries. European fisheries haven't done huge amounts of damage to their Lasmerbank fauna. They've exported the damage. They've effectively, through EU subsidies, fished off West Africa and caused all the damage. What I can't show you here today is the threat of deepwater sharks, but basically the threat of deepwater sharks spans all the way from Norway to Namibia, and that is solely due to deepwater trawling by the European fleet. The US is catching a lot of sharks, but the level of threat is rather low than you might expect. And that's because the US has been particularly careful in thinking about shark fisheries management. Indeed, the US can actually hold up its hand and say that we have managed to keep a population of sharks at BMSY. And they've done a whole series of other measures towards shark conservation. We often talk about Lifeboat Australia and Lifeboat United States, simply because they're the two countries that expend the most effort in chondrichthyon management in the world. Australia's got lots of threatened things, not necessarily because it's got lots of threatening processes there. Basically, these high threat levels in Australia are the edges of species that are centered in this area here. Of course, Northern Australia does suffer from a large amount of IUU fishing. We can think about finning and who's doing all the finning. The bulk of the world's finning is done by Spain, Singapore, which was a shock to me as I read this again this morning, Taiwan, Indonesia, United Arab Emirates, and Costa Rica. But finning isn't just restricted to these countries. All of these countries are contributing to the removal of fins and trading of fins towards southern China and Hong Kong. So let's go back to Huxley's question. Are fisheries exhaustible? Well, if you think of chondrichthyons as being fisheries, which I think it would be incontrovertible to say that they are, then clearly they are exhaustible. Fisheries for sharks, intentional or otherwise, are incontrovertibly elevating the threat and risk of extinction to sharks, and particularly a substantial proportion of them. We can go back to Huxley's model and ask whether the pattern of risk is predictable. And it turns out the pattern of risk is. So we've got 4 panels here representing different dimensions of depth, but you could focus on any one of them. Basically, all of the species that are not threatened are on this green rug here. The species threatened are in this red rug. And the x-axis is maximum body size being approximate measure of the intrinsic rate of population increase, or the capacity of the species to replace numbers lost to fishing. These 3 bars, go back. These 3 lines are the median in the middle, the upper quartile and lower quartile of each of these depth measures. So at the top panel we have the upper depth, so the height you are in the ocean water column, the median of the depth, the maximum depth, and the depth range. You can see that for a given body size, depth significantly influences your risk of being threatened, such that if you've got a shallower distribution overall, then you're more likely to be threatened than another species with a deeper distribution of the same body size. So this is support for Huxley's model. Basically, your probability of being threatened is a function of your exposure and accessibility to the fishing fleet and your intrinsic sensitivity and capacity to replace the numbers lost due to fishing. So if, like any other feeling human being, you're feeling concerned at this point, I hope to cheer you up somewhat before we close. So I'm just going to talk about progress in terms of conservation action plans, FAO national plans of action, fishing and finning bans, and international treaties. I could show you hundreds, if not thousands, of photographs of this piece. This is the sawfish. Here we have a large sawfish. These things can get up to 7 meters long. Russian trawlers in the 1950s were catching sawfish with blades as wide as my body. These are small sawfish. These are now both listed on the Endangered Species Act of the United States. These were pretty much found throughout the world's coastal oceans, particularly associated with low salinity environments. They're found throughout the Amazon River Basin. But they've been virtually eliminated from throughout the coastal waters of the world. Historically, these species were known to be found in the coastal zones of 101 countries. And we're now undergoing a process of assessing their status. But all 7 species are critically endangered. That actually makes them the most endangered, threatened marine fish group on the face of the earth. So we have this enormous conservation challenge. It's not like terrestrial conservation where you've got an endangered bird living on an island because the rats are eating its eggs. You've got a one country, one governance problem. We have a problem where we've got to convince 101 governments to do something about sawfish. So the way we're going to do this is we're going to have a preliminary workshop in London Zoo to bring together all the key people who actually know something about the conservation and management of sawfish. I think it was in 1998 the FAO instigated a national plan of action for sharks. So countries signed up, or not as the case may be, to produce national plans for sharks. And at first blush, this seemed like a very positive conservation and fisheries management framework for sharks. The key thing to remember is that it's absolutely non-binding. There are only 2 countries in the world that really take this seriously, and it's the US and Australia. But there has been progress. This is the increase in the area of EEZs of the countries that have signed up and have produced national plans of action. Now, I don't want to burst the balloon, but that's only 5% of the world's EEZs that catch sharks. So we've still got a long way to go. For those countries that do not have the technical capacity to produce this moderately complex document, particularly island nations, we're seeing this trend for shark fishing bans, where the nations are going, well, we don't have much shark catch, but we don't want to get in trouble with the international community and our tourism business. So we're just going to, in some way, shape or form, eliminate the catch and landing of sharks. There's no one way to describe the efficacy of any of these measures. There's no one way to evaluate it. But, you know, it is what it is. There has been a rise in the bans, and you can take from it what you will. At the very least, it shows an interest and concern in the problems faced by convictions. Moving to the finning issue, when countries say they have finning bans, they very often mean they land fins according to a fin-to-carcass ratio. This basically means the fins are brought back to one port and the bodies are brought back to another port. This is a nightmare from a point of collecting statistics on which sharks are being killed from where. So the very first step in shark conservation is to bring the bodies home with their fins on so we can identify them, measure them, and account for them. So we produced this shark fin report in Europe where we tried to persuade EU to move towards a fins attached policy. And they seem keen. So it might take a year to go beyond the executive arm, but the noises are positive. It's taken probably 8 years to get to this stage. And this, to be honest, this was a champagne moment for everybody involved in this, but we still have to go through the remains of the EU bureaucracy just to count the bodies. Not to do any conservation, just to count the bodies. There have been species listed on CITES. These are some of the first marine fish species listed on CITES, the Convention on the International Trade in Endangered Species. So these were watershed moments in conservation, whereby conservation treaties were used to deal with the fisheries problem. But we still face this problem that none of these were really subject to major fisheries. When we now bring species to CITES and propose them for listing, we're seeing them being thrown back in our face, mainly due to the financial interests of certain large countries. But there has been progress. This, even though these species were not listed under CITES, it has had a trickle-down effect through FAO and the regional fisheries management organizations to the point where particularly ICAT has been particularly strong in implementing a ban on capture of, I think it was oceanic whitetip, and they're moving for measures on hammerhead and shortfin mako. So it has helped the scientific consensus at these RFMOs persuade their constituent countries that they really do need to do something about sharks. Another treaty that the US has used to good effect is the Convention on Migratory Species. And there's a whole series of sharks that have been listed on the appendices there, which it's a fairly nascent treaty, but it does mean that countries are bound to protect habitat and forego the disturbance of these animals. There's massively increased public awareness. It's absolutely unbelievable how many news stories are coming through. And if you want to keep track of this, then you could go to the IUCN Shark Specialist Group Facebook page, which has 3,000 members. Our webpage has got 10,000 unique viewers each year. I never thought there would be 10,000 people interested in shark science in the world, but there clearly are. So at this point, I'd like to end there, and I hope I've compelled you, without depressing you too much, that it's incontrovertible that fishing, habitat loss, and increasing climate change have altered biodiversity in our oceans in a fairly permanent way. But I am very hopeful. You know, we had 10,000 years to do damage on land, and it's only now that we've got the strength of management to do the spatial planning to avert the biodiversity crisis on land. We've only really been seriously fishing the oceans for 100 years. And sure, we've lost lots of biomass, and we might have lost a bit of diversity, but it's not beyond our powers to make sure that not just the target fisheries are sustainable, but also the bycatch. And indeed, if you're ever thinking about the ecosystem approach to fisheries management, what else do you need to do apart from make sure the target species are sustainable, make sure the non-target species aren't going to go extinct, and let's conserve some habitat? How complex does the ecosystem approach have to be beyond that? In addition to thanking 306 people involved in the red listing, I'd just like to thank my collaborators and all of my lab members who contributed to this work over the last decade or so. Thank you very much.
There's time for some questions, so I think I'll throw you to the sharks.
So the line of the captain. So I welcome any feedback, positive or negative. Any questions?
You didn't mention anything about the shark fin bans in the United States on the West Coast and Hawaii. Do you think that they have been beneficial for shark conservation, or do you think that you're only exacerbating another part of the world by increasing the price of shark fin?
What do you mean by shark fin ban?
Well, there was a ban, right, in California, Washington, Oregon, Hawaii. Does it ban the
Right, so these are municipal
trade?
bans. Yeah. Okay, I'm with you now. So I could give you a whole variety of answers, depending on whether or not I've got some beer in my hand. The key question to think about is, to what degree is that actually, in a measurable way, contributing to the conservation of sharks? What's the bang per buck? And what's the cost of doing that? And the benefits of doing it, I think it aroused and revealed an enormous swath of public opinion and concern about shark finning. And that captured it in a way that the rest of the scientific community has never been able to do in the last couple of decades. So that's a very, very positive thing about it. The negative thing is that it's top-down Big Brother control. It's imposing a societal choice that society hasn't necessarily voted for, or a sector of society hasn't voted for. So it's effectively alienated the Chinese communities of those cities. And if ever there's a bunch of people you wanted to be on your side, it's Chinese people, really, in this process. So I'm personally more in favor of raising awareness amongst consumers rather than imposing your value system upon them. How would you feel if somebody said to you, you're not having turkey for Thanksgiving? That would be a pretty bad moment, I'd say. And that's effectively what we fans are saying to the Chinese community. And we face this in Vancouver. But we've got a better solution in Vancouver, I think. So I work with an NGO called the Shark Truth. I'm a scientific advisor for the Shark Truth. And the Shark Truth is run by Claudia Lee, who was a business graduate at SFU, who took a sustainability module. What's this shark fin soup story? Oh my goodness, I can't believe I ate that stuff. So she started an NGO to raise awareness of this. And she did this in a really smart way. She basically went to all the wedding planners in Vancouver and went to the wedding fairs and set up a competition whereby wedding couples could enter the competition if they pledged not to serve shark fin soup at their wedding. So the first year they ran it, they had a total of 38 couples to pledge not to serve shark fin soup at their wedding. So you might go, well, that's 38 weddings, that's 4,000 sharks worth of shark fin soup. You might go, that's a drop in the ocean, but I go, well, that's my full population of shark. But the other way to look at this, and this is a really powerful way of looking at this, is to go, well, that's 4,000 people who learned about the problem of shark fin soup. So all of these weddings, people had to communicate the reasons for their choice. All the tables had little cards on. There were massive posters and placards all over the wedding. It's absolutely amazing the degree to which this process has empowered young Chinese couples to actually break with tradition and do something that goes more with the grain of their upbringing, maybe a second or third generation Chinese person living in Vancouver. So they've now had 3 wedding competitions. They've now had a series of competitions to try and find alternatives to shark fin soup. So we've now had a situation where about 100 couples have pledged not to have soup over the last 3 years, and several thousand sharks have been saved, or their death has been forestalled by this process. But the key thing is, I think it's raised massive awareness in the Chinese community in Vancouver and a massive interest in doing something different. So they're now working on a campaign to persuade the key restaurant, the key Chinese restaurant in Vancouver, to not have shark fin on its menu. So that's their goal for this year. So I personally would rather work with awareness raising rather than imposing legislation that has massive problems with it. So one of the unintended consequences of that legislation means that skate wings are technically shark fins. So all the guys who catch skates can't technically now trade or possess skate wings in Oregon. So I could go on about that for ages. Next one.
So that was really terrific talk. I really enjoyed that. I'm just curious, some of what you showed makes it look like the majority of the harvest of sharks is unreported and probably not being subjected to any fisheries management. So to what extent do you think that this growing acceptance of new regulations on sharks is having any impact at all if
That's $1 million question.
are not plugged into it?
Yeah, that's $1 million question. And we thought about this because within our community of the Shark Specialist Group, there are fisheries managers, and a lot of them from the US, and they have never been to a fish market in Dar es Salaam. They have never seen some of the things that are blindingly obvious to people who are a developing world country. So there is a very live and real debate about extinction risk within the group. They go, well, it's critically endangered. You can't say it's critically endangered. You're telling us it's going to go extinct next year. And that's not the interpretation. It's an elevated risk of extinction. So that debate goes on within the group. But I step back and try and persuade them that there genuinely is a problem, because it's hard for somebody sitting in Juneau, Alaska to really feel the consequences of those maps. 140 or 150 species in a cell in Southeast Asia is threatened with an elevated risk of extinction. There's a lot of extinction risk. So it's hard to convey that. So I turn around to them and go, well, how many sharks are we actually sustainably managing with the stock system? And we just recently did a cursory review of that. We think that 5 populations of a handful of species of shark are actually sustainably managed with the stock assessment that you might consider to be a reasonable stock assessment. That's a drop in the ocean. Really, it's frightening. And basically, outside of the US and Australia, there's effectively no shark management. There's no capacity within management agencies. I worked in the UK Government Management Agency, and there was no single person there paid to do anything for sharks. It's absolutely ridiculous. So I am very, very concerned that the rise in national plans of action, the rise in these shark fin bans, are just a veneer to make us think that there is something happening. They're effectively the equivalent of paper parks. So what we want to do now is we want to re-redlist all the sharks. We look at 10 years on, what is the status of these sharks, and has their status changed as a consequence of any of this management activity? So you could ask, is it more likely that their status is improved in countries with national plans of action of varying quality? So that's what we want to do. We want to effectively create a red list index of sharks to actually definitively ask whether any of this management is effective in forestalling further risk of sharks. Over on the right there.
Yeah, so apart from one of the people who's done one of those 5 stock assessments of
Thank
sharks, the question, and I'm thinking in the Australian context of fisheries management, you can divide the stocks into 2 groups. The ones that are target species, in which case you've got the resources, and you've always got the incentive to manage sustainably because people are making a living out of it. And then you've got the bycatch. The motivation to even almost do research on bycatch is pretty limited because the net consequence is generally the fishery gets curtailed for something that's really not worth anything. How do you see dealing with that group of species, and I'm presuming that a vast bulk of shark bycatch, let alone turtles and other things, are literally bycatch. They're not targeted species. People might make money incidentally by keeping fins or whatever. But ultimately, people are fishing for other things. How do you change? What's going to motivate people to do something about that?
I actually came here to find your answer to that question. No, I'm genuinely serious. I very rarely get down to the operational details of fisheries management, and within sharks there are so many of these kinds of problems. How do we do something when there's no financial incentive to do anything about it? And I think my probably crass and shallow answer will be that I think you have to remember that if you're a signatory to the Convention on Biological Diversity, then you are committed to do that for reasons other than financial and economic reasons. So by being a signatory of the CBD, you're committed to a whole series of other values of biodiversity other than their direct economic value. And those elements come into play in virtually other areas of terrestrial conservation. So why should they not come into play for sharks? So this is a large part of the reason why we spend a lot of time communicating the value or values of sharks. Because I think people, you're well aware of this. I'm not really answering this for you, but to communicate my position to the rest of the audience. I think we want to communicate the wide range of values of large swaths of marine biodiversity. And this is why things like Finding Nemo and our analyses of the Finding Nemo film are actually important. There may not be hugely important scientific contributions, but I think they're very important contributions in terms of shifting the public mindset by biodiversity. They're not just eyelidless, slimy little things. They're biodiversity that we should care about. And we're actually seeing that the public perception of value of biodiversity is working its way down the tree of life. So in the 1960s, we only cared about a handful of mammals. Maybe we cared about whales. Maybe we cared about a couple of primates and some birds. Well, with the advent of the IUCN red listing process, as they work down the tree and reveal all of these results and some of the uniqueness and quirkiness of the life on Earth, then the public has really moved along with that. So, you know, the transformation in the public care for sharks is just phenomenal since Jaws, for example. So I put it to you that the Australians have signed the CBD, so, you know, if you're going to commit yourself to that international policy, then you should just man up and protect the sharks for their value. But of course, you know, money talks. Sorry, and I'll get you a minute. Yep.
Just a numbers question. You said there are about 38 million, I think, each year, but I've heard numbers higher up to 70.
Right. This is a really interesting question. I can't quite remember the exact numbers. But Shelley Clark's estimate was a Bayesian estimate. It was a composite book that went from about 26 to 77. Conservation NGOs tend to pick off the 77 number. And even the Shark Truth, who I work for, I continually say it's not 77. And depending on what day it is and who the audience is, Claudia says 77 or 38. So Shelley Clark is, I think, writing an article at the moment on the use of scientific information based on the way that number is being used.
And then it's for other deaths. I've heard numbers as high as 100 million.
Yeah, I can remember when I was at grad school, the 100 million mark was out there. I've no idea where that came from. Does anybody else know? I presume it's just an extrapolation of the FAO catch. But since Shelley Clark's study came out, that 100 million number has been superseded by the 77 million, which is the upper 95% travelogue. Daniel.
Just thinking about your story about the wedding planners, and just thinking about how the conservation movement in North America, Western Europe, has really been, I think, enabled by economic prosperity of urban citizens. Think about where China's going with its economy and its rising prosperity. I mean, is that where the major opportunity exists for education and changing the fate of sharks?
I think so. There are similar NGOs working on Hong Kong. There's one called the Bloom Foundation, who did a recent survey, just straw polled people on the street and said, you know, would you eat shark fin soup? And a surprising portion of people in Hong Kong said no. Now, it was clearly a scientific, unscientific study and unsystematic and so on. But the very fact that they had large portions of people saying, no, I'm not interested because of the consequences of shark finning was, I personally thought remarkable, but I would like to see a more systematic study. I would like to see Claudia and her gang move to China. You know, the Chinese government's a technocracy. If they want to change something, they will, and they will do it in a very effective way. So it could be surprisingly simple to persuade to create a social tipping fund in China to do something about this. But it's not just shark fin, so I just want to expand it out a bit. I would just want to say that at a Chinese wedding, it's an opportunity for you to share your wealth. It's pretty much the only opportunity. So that's why there are big weddings, and that's why you have these high-value products like shark fin soup. So they serve one of the big four Chinese weddings. So it's sea cucumbers, shark fin, fish swim bladder, and abalone. And if you know anything about the conservation status of any of those organisms, they're in trouble. And generally, if you look at a lot of marine trade is one of these really difficult problems that are poorly characterized. The perceptions are bad about it. So even within Traffic WWF, who manage trade, they totally brush marine trade under the carpet. But there's vast quantities of stuff. Like the trade in shark fins is worth $0.5 to $1 billion a year. The trade in aquarium fish is worth several $1 billion a year. The live reef fish trade is worth several $1 billion a year. You know, these are vastly economically important things, and we're not capturing the taxation from that with which we could use to manage these systems. So trade is totally falling between the cracks, but I'm digressing from your question. You know, I think I'd really like to try the chance to see if we could do something about gin public in China in a smart way. It wouldn't be me doing it. I think it has to come internally from Chinese citizens. Any other questions? Yes. Last question.
Just have you guys done much with promoting bycatch reduction, especially in the pelagic longliners, because they do have an economic incentive to not catch the sharks, because that's the one hook taken away from the tuna?
It depends on whether they can sell on the fins. Fins can sell for about $200 per kilo, so maybe they don't have the incentive, and I don't know the specifics of the US system. And one of the big things about finning on pelagic boats is the fin money goes straight to the crew, so that it's their only direct income apart from whatever slice they get out of the tuna catch that trickles down to the skipper and the employer. So the individuals on the boat are strongly incentivized to fin. Obviously, if you've got to bring the bodies back whole, then that changes that incentive structure. Then it's part of the skipper and the total boat share. And there's trade-offs. Obviously, if you bring sharks home, you can't bring tunas home. So this is why people are so resistant to this fins attached rule, because they know it's going to curb their fishing effort. Am I off the hook? Is it beer o'clock?
Beer o'clock. Please come and join us. We're like reception afterwards.